The Nobel Prize in Physics for 2025 was awarded earlier this week, and it went to these scientists for their discovery of macroscopic quantum mechanical tunneling and energy quantization in an electric circuit. But what does that all mean? Normally the universe can be divided into two worlds: the classical world, which describes everyday objects like baseballs and cars, and the quantum world, which describes tiny things like atoms and electrons. But the work behind this year's Nobel Prize blurs the line between those two worlds. They essentially created a macroscopic or classical system, one thing made of many things, but it behaved like a single quantum thing. John, Michelle, and John built a tiny electric circuit, about a centimeter across, made from materials that let electricity flow through them with no resistance, called superconductors. Between these superconductors, they added a thin layer that blocks the flow of electricity. Now, inside a superconductor, electrons pair up and start acting together as one giant particle, essentially creating a macroscopic system, or a single thing made of many things. And that's when things got a little quantum-y in their experiment. They observed a process called quantum tunneling, where something can pass through a barrier, something that should be impossible in the classical world. Like, imagine throwing a ball at a wall and having it magically appear on the other side of the wall. That's tunneling. The circuit was initially trapped in a state where current flowed freely, but the system was held behind a theoretical barrier as if there was a switch stuck in the off position. But unlike a switch, there's a barrier stopping the switch from moving to the on position. Without quantum mechanics, this stable state should never change. But they observed the collective escape of multiple Cooper electron pairs acting as one single unit, as if they were one single particle, which proved that tunneling was occurring on a macroscopic scale because it was a classical thing made of many things behaving as a single quantum thing. And this escape was registered as the sudden appearance of an electrical voltage in the circuit. Now, John, Michelle, and John also found that their circuit only absorbed or released energy in discrete packets, or quanta, which is another quantum-only behavior. So that's their discovery, which proved that even a system made up of lots of particles can act like a single quantum object, blurring the line between the classical and quantum worlds. Congratulations again on the Nobel and for officially breaking my brain. Hopefully that made sense.